In this lecture, we turn to the most important tool of analysis in economics, the supply and demand model. In this chapter, we're going to talk about what are the market forces of supply and demand that help determine the prices of perfectly competitive markets. We will discuss the factors that affect buyers' demand for goods and the factors that affect the seller's supply of goods, because these are the two sides of the market, consumers and firms. How the supply and demand determine the price of a good and the quantity sold in the good. And then we're going to make an analysis of how changes in the factors that affect demand and supply affect the market price and the quantity of the goods. And then we're going to talk about also how do markets allocate resources. Remember that the topic of economics, the object of study of economics, is how society manages its scarce resources, and we will see that the forces of supply and demand is one way to allocate these resources. Throughout the semester, we're going to be going back to revise whether the different models and the different market structures do a good job in allocating resources. But we have to define what good is, and we're going to do that later in the semester. So we're going to be talking about markets. And what is a market? A market is not a location. A market is a group of buyers and sellers of a particular good or service. So we're talking about a group of buyers that determine the demand for a product and a group of sellers that determine the supply for the product. And in markets, interactions of buyers and sellers are going to determine the market price and the quantities that get sold. It is important to be clear from the outset what is the type of market that we're talking about. We're going to be talking about a perfectly competitive market. So in a perfectly competitive market, this is a market that we describe as a market with many buyers and many sellers in such a way that each has a negligible impact on the market price. So each market, each individual buyer and seller is small compared to the rest of the markets. And also the good that gets produced in this market or the good that different firms can supply to this market, it's exactly the same. It's identical. So an orange is an orange, an apple is an apple. In the real world, there are many markets that we're used to where product differentiation is important, but we're going to start with this simplified version because it helps us to understand a great deal. It gives us many lessons. And then we can use this as a benchmark to compare other market structures. For example, when we just have at the opposite extreme, when we just have one firm providing the whole market rather than many sellers. And whenever we have product differentiation. So when we're thinking about like clothes, smartphones, and things like that, that two products have a different qualities and they're differentiable from one another. So those are different types of models, different types of market characteristics that we're going to analyze separately. We start with the perfectly competitive market model as a benchmark. We will start with the buyer side of the market. So buyers determine the demand for a product, and the quantities demanded are the amount of a good that a buyer is willing and able to purchase. So there is something about the preferences of individuals that determine a willingness to purchase a good, but also there is some elements about the purchasing power of an individual that makes him or her to be able to purchase a good. So the quantities demanded are going to be based on these two elements. And thinking about the buyer side of the market, the most important thing to keep in mind is what we call the law of demand. The law of demand says that other things equal, when the price of a good rises, the quantity demanded of the good falls. So this is very important. When the price of a good rises, the quantities demanded of the good falls. And also the converse is also true. When the prices fall, the quantity demanded rises. So this is pretty straightforward, yes? So when a good becomes more expensive, what we do is we reduce our quantities demanded. When a good becomes cheaper, we increase our quantities demanded. And this is the law of demand. So think about the demand for a good. And in particular, we're going to think about the demand for lattes. So we're going to write down what we call the demand schedule. And the demand schedule is just a table that shows the relationship between the price of a good and the quantity demanded for that good. And we're going to do the demand schedule for a single individual like you and me. We have certain preferences, we have certain level of income that is going to guide us in making a decision of how much are the quantities of that we're willing to buy of a good at different prices in the market. So we're going to do that for Sam. And this might be the demand schedule for Sam. So what it is that we have here? So we have the different combinations of prices and quantities of lattes demanded. So here we can observe that at a price of $0, then Sam would demand 16 lattes. Yes. At the price of $1, he demands 14 lattes. At $2, he demands 12 lattes. So on and so forth. You see what this shows, right? It shows us the quantities that Sam wants given different price levels that he can pay for all lattes. Yes. And you can see that the way that this demand schedule is written down, it obeys the law of demand, which says that as prices go up, quantities demanded go down and vice versa. With the data from the demand schedule, we can plot what we call a demand curve. So the demand curve is just simply going to be the graph of the demand schedule. So we have the same data about the demand schedule here for Sam. Now we want to plot it into a graph where we have the quantities on the horizontal axis, okay? And we have the market price on the vertical axis. So that's what we're going to be looking at throughout all this presentation. So at the price of $0, so when lattes are free, then Sam is going to demand 16 lattes. So that combination of price and quantities is shown as this dot right here along the horizontal axis. So we call this the x-intercept, right? So that's the value of the curve that we're going to draw when the price is 0, the quantities demanded are 16. And similarly, for a price of $1, now with a higher price, it's not free anymore, the quantities demanded fall. That's what we call the law of demand. Now that since it's more expensive, then Sam is not going to buy as many now that he has to pay for it. Yes. So according to his demand schedule here, then at the price of $1, there are 14 quantities of latte that are demanded. At the price of 2, 12 quantities of latte are demanded. At a price of 3, 10, so on and so forth. You get the picture, yes? So the demand schedule shows us the different combinations of price and quantities demanded for a particular individual. And here in this table, we just have a certain set of prices in units of $1, but we can imagine that there's an infinite number of units in between. So if we plot all those different units in between, we come up with a straight line. And this straight line is what we call the demand curve. And the demand curve, pretty much notice that these two things, the table and the graph, they are exactly the same thing. They are just two different representations of the same thing. The willingness and ability of Sam to buy a good at different prices that he can buy them. Yes, we can have it in terms of data, or we can have it in a curve like that. The same information represented in different ways. That is the demand curve for Sam. But if we're interested for the market demand, then we have to add up all the individual demands for a good or a service. So we have to add up the demand for Sam, for Becky, for Charles, so on and so forth, right? So what we're going to do is we're going to add up the quantities of different individuals at the same price level. So when you and I go and to buy a latte, yes, we are paying the same price for a given amount. So we want to, if you and I are the only two individuals in the market, then at each market price, the sum of the quantities that you and I are willing to pay, that is the market demand, the quantities demanded by the market. So we refer to the market demand curve as the sum of the individual demand curves horizontally. Sometimes we call it the horizontal summation of the demand curves. Why? Because what we are adding up are the quantities demanded. And in our graphs, the variable of quantities is on the horizontal axis, yes? So we are adding up horizontally in that way because the values of quantities are on the horizontal axis. Suppose there are only two individuals, Sam and his quantities demanded. This is the same information of the SAM's demand scale that we showed in the previous slide. And let's suppose that now we have Dean. Dean have different preferences, have different income, so the quantities demanded by Dean are going to be different at each price level. So for example, at the price of 1, Sam demands 14 units, Dean demands 7 units. So assuming that there's only 2 individuals in this market, of course there's going to be many millions of individuals, but just to make the math tractable, suppose that there are only 2 individuals, then the market demand for the market for lattes is going to be given by the sum of the quantities demanded of each individual. So adding up at each price, so for Sam 16, for Dean 8, that's a total quantity of 14 lattes in the market at the price of 0. Then adding up at the price of 1, the market quantities demanded, it's 21. So on and so forth, you get the idea. So what we're doing is we are adding up the variable quantity for each price level. That gets us a different amount of quantities, the market quantities, and we can plot that in the graph too. Here's how it looks like on a graph. So what we have here in this table is the quantities demanded in the market, so that is the last column of the previous slide, and the market prices. So it just looks pretty much the same. Okay, it looks downward sloping. It shows an inverse relationship between prices and quantities demanded. Yes, so the market demand curve for lattes, it's also going to be obeying the law of demand. This is quite straightforward. Now, when things starts getting more interesting is when we start thinking about the other determinants of the quantities demanded. So of course, the price of the good is an important determinant in the decisions of individuals to decide how much quantities to demand. But there are also other things that affect the quantities demanded. So when we are plotting the demand curve or we are writing down the demand schedule, this is showing how price affects quantities demanded, other things being equal. And what we mean by other things being equal, it's everything else, like the level of income, the number of buyers and sellers in the market, the price of substitutes or complements for the good, the preferences of the individual, or expectations about prices in the future. All those things that would also matter to determine the quantities that you demand for a good that would affect it, they would shift the demand curve. Changes in the price of the good itself is shown as a movement along the demand curve. By definition, that's what we are plotting in the graph. It is how quantities demanded change when prices are different. All right. So any other determinant of the quantities demanded, except for the price of the good itself, it will shift the demand curve. Here are the most influential variables that affect the decisions of buyers and will affect the quantities demanded. So if we think about the price of the good itself, so we're thinking about the price of good X, then a change in this variable, a change in the price of good X, is represented as a movement along the demand curve. Okay? However, if we're thinking about other determinant of the demand, like income, if we're thinking about changes in income, that will shift the demand curve in the ways that we're going to describe in a moment, right? Another demand shifter is the price of related goods. So if we're thinking about the demand for good X, then we have to think about how changes in the price of good Y will change the quantities demanded for good X. And whenever making this analysis and there are changes in the prices of another good, that will shift the demand curve for this good, right? So we're going to be referring to good X and good Y when talking about two different goods. And pretty much what we're saying is that the prices of good Y is going to affect the quantities demanded of good X. And this will be represented as a shift of the demand curve for good X. Tastes and preferences for a good, expectations about the future, and the number of buyers, all of those things are factors that affect the demand for a good other than the price of the good itself. So all of those factors are going to shift the demand curve. Changes in the price of the good itself, its movements along the demand curve. Let's start looking at a few of these demand curve shifters. So suppose that the number of buyers increase in the market. So you have an increase in the population or more migration. What would that do to the market demand curve? Well, at each price level, now with more buyers, then this is going to increase the quantities demanded. So the way that we showed this is as a shift of the demand curve to the right. So there are more buyers now at each price level. So no matter what the price level is, now we have more buyers. When we think, and it works the other way around. If there's a decrease in the number of buyers, then there's going to be a decrease in the quantities demanded at each price level, and we would represent that as a shift of the demand curve to the left. Here's a graphical representation of an increase in the number of buyers on the demand curve. So suppose the number of buyers increases, then at each price level, the quantities demanded are going to be higher. So here we're going to assume that there's an increase in 5 buyers. So at the price of 0, if the quantities demanded was 24, now the quantities demanded are 30. At the price of $1, if the quantities demanded were 21, now the quantities demanded are going to be 26, so on and so forth. You get the idea for other prices. So the point is that when you have a higher number of buyers, the quantities demanded are going to be higher at each price level. And the way that we're going to be showing this in all of our graphical analysis of markets is as a shift to the right of the demand curve. Okay? So that's the way that we represent it. So we would say that the demand curve shifts to the right from the blue line to the red line. All right? And it also works the other way around. If there is a decrease in the number of buyers, then in that case, that would be a shift to the left of the demand curve.
Another demand curve shifter is income. So how do changes in income affect the demand for a good? Now it might sound obvious, but the only right answer is it depends. For most goods that we call normal goods, an increase in income leads to an increase in the demand, and it will shift the demand curve to the right. That is most things that we can think about. Clothes, cars, and almost everything that you can think about. Well, there are a few goods that actually move in the opposite direction than income. We call these goods inferior goods. So when there's an increase in income that leads to a decrease in the demand, that would be considered to be an inferior good. And there are a few examples of inferior goods you can think about. For instance, canned meats as an inferior good. So when incomes go up, people can afford more of other higher quality meats and they buy less of canned meats. Another example could be, well, in general, low quality products or low quality brands are probably inferior goods, right? As income increases, then people buy fewer of these low quality products, and the other way around. As income falls, the demand for low quality products go up. So those can be considered to be inferior goods. Public transportation is another example of a public good. As incomes go up, families can afford cars, and they would take more families would be able to afford cars, and there would be less public transportation. And the other way around, when incomes go down, some people give up their car and then they start using public transportation. Or you can think about used cars being an inferior good too. When income is high, people buy more new cars. When income is low, people buy fewer new cars and they buy more of used cars. So used cars are probably an inferior good, whereas normal cars are, new cars are a normal good. So it depends on the good that we're talking about. Another demand curve shifter is the price of related goods. And in particular, it depends of what is the relationship between that related good and the good that we are analyzing. For example, when we have goods that are substitutes, that's going to have a different effect on whether a good is a complement. So for example, we say that two goods are substitutes if an increase in the price of one good leads to an increase in the demand for the other good. A clear example would be pizza and hamburgers. Whenever there's an increase in the price of pizza, then we would expect the demand for hamburgers to increase. We would expect the demand curve for hamburgers to shift to the right. Why? Because as pizza becomes more expensive, some individuals buy less pizza and more hamburgers. They are substitutes. So this is the relationship that we would expect. Other examples are, of course, depending on brand, Coke versus Pepsi, laptops versus tablets, music CDs, and music downloads. There are many examples that you can think about. So we're going to show the relationship of substitute goods. So here we're going to think about two goods. On the left, we have the market demand for pizza. On the right, we have the market demand for hamburgers. We're going to label the demand for pizza as, or we're going to refer to the good of pizza as good X and the good of hamburgers as good Y. So let's see what happens when the price of hamburgers go up. As the price of hamburgers goes up, the law of demand says that the quantities demanded for hamburgers fall, and as a consequence, what happens in the markets of pizza? Since now hamburgers are more expensive, there's an increase of the demand for pizza at each price level. So all things the same, even if the price of pizza remains at the same at $7, there's going to be a higher number of quantities demanded at any price level of pizza. So we would show that as a shift to the right of the demand curve for pizza. So what we observe is that when two goods are substitutes, so we say that if good X and good Y are substitute, it must be the case that an increase in the price of good Y increases the demand of good X, or it shifts it to the right. And conversely, two goods are substitute if the price of good Y also lowers the demand of good X, or shifted to the left. So if these things happens, then we would say that two goods are substitutes. But not all goods are substitutes. Some goods are complements. They complement one another. So we say that two goods are complements if an increase in the price of one good leads to a decrease in the demand for the other. So here we have an inverse relationship between the price of one good and the demand of another good. So one example is computers and software. If there is less demand for computers, then there's going to be less demand for software as well. Okay, so for example, if the price of computers goes up, people buy fewer computers, and therefore there will be a smaller need for software. So the demand for software will also fall, and we show a fall of the demand as a shift to the left. So other examples are college tuition and textbooks, bagels and cream, cheese, eggs, and bacon, and we can have a whole list of them. Here's the graphical analysis of changes in the demand due to changes in the price of a complement. So let's suppose that we have an increase in the price of movie tickets. We have the demand for movie tickets in the right, and we have the demand for popcorn on the left. Suppose that the price of movie tickets goes up, say from $8 to $10. The law of demand says that the quantities demanded for movie tickets is going to fall, as shown here. What's going to happen to the market of popcorn? Well, since fewer people are going to the movie tickets, then at any price level, the quantities demanded for popcorn are going to fall. There's fewer moviegoers, and there's going to be less demand for popcorn as well. So that's represented as a shift to the left of the demand for popcorn. So here what we observe is, look at the direction of the arrows. The direction of the arrows here are different than in the previous slide. Yes, so when the price of good Y goes up, the demand of good X goes down. Why? Because there are complements. They are butt together. So a higher price of Y decreases the demand for Y and the demand for X. So the demand of X shifts to the left as shown in this graph. And the converse is also true. If there's a fall in the price of good Y, then the quantities of good Y are going to go up, and the demand of good X is also going to go up, right? Because X and Y are complements. If they are complements, this must be the relationship that we find. One last comment to make before we move on. Notice that in all this analysis, in all these changes that we're looking at, a change in income and change in the price of another good, here we are assuming that other things are the same. So whenever we are analyzing a change in the demand of good X due to a change in the price of good Y, we are assuming that other things are constant, okay? Tastes or preferences it's another demand curve shifter. Anything that causes a change in the preference towards a good is going to change the demand for that good. So, for example, diets go on and off they go in and out of fashion all the time. In the 90s, the Atkins diet was very popular. In the late 2010s, what's more popular is the keto diet, or a diet that includes fasting for prolonged periods of time. So those changes in those diet are going to affect the demand for certain goods. Like for example, the keto diet, it emphasizes the consumption of nuts and beans. Okay, so we would expect the demand for those products to increase as there is a preference for those goods. Expectation about future economic conditions are also going to be a demand curve shifter. So for example, if we expect an increase in income, then we might increase current demand because we expect that income to go up in the near future. If we expect higher prices in the future, that might increase our current demand as we avoid paying higher prices. So one example is if people expect their incomes to rise, then their demand for meals at expensive restaurants might increase now in expectations of those higher incomes. And typically that happens also when we get closer to the Christmas time. We expect there to be very good deals during the Christmas time. So just before the Christmas time, we might postpone certain purchases in order to take advantage of those great deals during the Christmas time, right? So expectation of falling prices in the future creates a reduction in the demand just before the Christmas time. Before moving on to the next slides, try to figure out the answers to these questions. Draw a demand curve for music downloads. What happens to the demand curve in each of the following scenarios and why? Okay, so you're going to be analyzing the demand for music downloads and think about what happens to the demand of music downloads if the price of iPods fall, or if the price of music downloads fall, or if the price of music CDs fall. In each of those instances, figure out what happens to the demand of music downloads and draw it. The best way to get this across is to practice, practice, practice. So think about them carefully. All right, so what happens to the demand of music downloads if the price of iPods fall? Well, music downloads and iPods are complements, yes. More people buying iPods, that means that there's going to be more music downloads. So if the price of iPod falls, people are going to buy more iPods. That's the law of demand applied to the demand for iPods. But what's going to happen to the demand for music downloads? Well, it's going to shift to the right. Now, as more iPods are sold, there's also going to be more demand for music downloads. So that's a shift to the right of the demand curve for music downloads. What happens to the demand of music downloads as the price of music downloads fall? Now be careful with this one. This is a fall in the price of music downloads. So remember, any change in the price of the good itself is shown as a movement along the demand curve, not a shift. So the only thing that is shown as a movement along the demand curve is the price of the good itself. So if the price of music downloads fall, then what's going to happen to the demand of music downloads is that it will stay put, and what we're going to have is an increase in the quantities demanded. All right, so there's going to be an increase in the quantities demanded, not the demand curve. Okay, and here we have to be careful in the usage of language. Whenever we are moving along the demand curve, we refer to that as for example here, as an increase in the quantities demanded. So the term quantities in front of demanded, that indicates that what we're talking about is a movement along the demand curve. That's the convention in economics. So that's the proper language and the proper usage in economics. Whenever I say an increase in the demand without having the word quantity just before demand, When I say an increase in the demand, that is understood in economics language as a shift to the right of the demand curve. So be careful when using that language. Lastly, what happens to the demand of music downloads as the price of music CDs falls? Well, music CDs and music downloads are going to be substitutes, yes. So if the price of music CDs fall, then there's going to be a higher demand for music CDs and a lower demand for music downloads, or things the same. How do we show that lower demand for music downloads? That's going to be shown as a shift to the left of the demand curve for music downloads. And that means that at any price level of music downloads, there's going to be lower quantities demanded now because the price of music CDs has fallen.